Okay, hello everyone. I will show you a small Arduino shield for the Arduino Mega 2560. And we call this shield or project ZyklenAutomatik for Arduino. This project starts in the German CNC forum CNC-Ecke. And the basic idea is to build open source and open hardware electronic gearbox for lathes, and this is my interpretation for Arduino shield to control the Arduino. And yes, I will show you this video the first functions. And for the main idea for the electronic gearbox for spindle synchronization, we only need the signal from a rotary encoder from the spindle, and we need a motor for the ZX. And we use a step direction signal. And I think now I show you my mechanical components that we have a look how it looks and how it can be worked. Now this is my small CNC, and here is a rotary encoder. This is a stepper, a rotary encoder with differential drive here in this cable, and this is only for the speed controller. And this is my signal for Linux CNC. And yes, that has a encoder has now resolution with 400, but it's possible to change it inside. And the lathe have no ball screws or something like this, and can use this X manually. But I have for other functions a step driver on the X axis. Now here's the test thread, and yes, I think that's all. And it's important to know that we use a Breezen-M algorithm this time, and that means that the resolution from the encoder must higher than the steps per resolution from the motor. And yes, but there are small tools to calculate it. These are the drivers for the steppers. And here are small PCBs to adapt the cables and a 24-volt power supply. Okay, this was my first idea. And on this PCB we only have motor output and encoder input, and another input for non-differential encoders. With these jumpers you can set the input for the encoder, differential drive or without the differential signal. And yes, that was the first and easy idea, and it works pretty good. And then I have to think about it, because on my lathe I have XX, and I want to drive the XX manually, but without computer and without Linux CNC, just with this small shield. So I added a second encoder input, and I added a second motor output. And for the manual control I use these encoders, and I have here 3 wires for selection switch for the X or Z axis, and 1 wire for other operations. This is 3, and yes, I make controller to build in, and here the switch and button. Okay, at the front we have here in this point output LED. That's the output LEDs from this motor A and motor B output. And here we have buttons and the menu buttons and the operation buttons. And here are status, outputs, and power LED, and we have here a rotary encoder. Okay, at the back we have the we call it POTI for the contrast of the LCD, small tweeter for acoustic signals, make beep beep or something like this. This port for the motors, for the encoders, and for the non-differential drives and limit switches. And potential free output over a relay, and we have here a keypad for keypads like this. This was my first idea, but I think we can use this output and inputs for other functions. Here's the GND and 5-volt signal too. Here are some small soldier jumpers, and we have here the normal jumpers to jump between this input from the encoder, and with this we can set 5-volt to this port, or you can use external 12 volts or 24 volts, what you like. Okay, now this is a original Arduino, but it works with other Arduinos. I think the layout is more or less the same. Here these capacitors are sometimes more in this position, but it works. I think it's no problem. Okay, now I need the power cable. And we can start it up. And just a small look at the menu. This is something like edit cursor, and goes up and down, and I can set here some functions. And the edit value can be set in the software. So here is it 1 millimeter, and here it's a smaller value. And with this buttons, I jump to the sides for the functions. And threading, grinding, cutting, moves, and options. And okay, this is something like a button menu. I can, now with these buttons, I can drive ZX, and I can hold it and move, or with slow speeds. The speeds are defined here, and I can go to this action when I press this button, and I can go out with this button. This is an indicator for the function, and here the button menu change. So in this operation I can say go, stop, or return. These two buttons are for stop, and this is for go, this is for return. I will show you the functions the next. Okay. I think that's all for this, and the idea with a motor and encoder for the x-axis to make the future operation for cutting automatically threads and cutting tapers with an angel and cutting bolts. So you have more or less a small CNC lathe, but with a manual control. And for the future, I hope it is possible to edit the GRBL library to control the lathe over G-code and the computer and Arduino. All the software is open source, and the layout, the PCB layout, is open source too. And the size of this PCB is 10 centimeters to 10 centimeters. I've choose this site because it's cheap to send the Java files to the PCB maker Seed Studio or something like this, and then you can order 5 layouts for more or less, I think, 25 euros. So I think that's a good price. For 5 euros you have one of these PCBs, and it works. And the other components are codes more or less 20 euros. And you need the Arduino Vega. Okay, now I can show you the main operation for threading something, and I can show you some more functions, and we can async the pitch. This pitch is, I make 1.5 millimeters, and length I think is this, and I set it to 0 and say okay, go this. I can say return manual or return automatically. I say automatically and start to spin. Now I just can say here and fire it up. And it returns automatically very fast, so we can define this delay time in the menu. So I can stop the spindle and turn it, and the motor moves. So you know it would be calculated over the Boolean algorithms, and I can start. Okay, go back and start again. I hope you have your luck, but I think it's not easy to see, but it works pretty good. Okay, now I can say stop and go. These buttons now are the moves. The default, rapid, and slow move. I can go here, and go. And for easy operation, when I only put at one time, it goes 5 millimeters. And here with slow moves, it makes 0.5 millimeters. Or I can hold it. Okay, and I set it to 0. Okay, now we have a grinding operation, and the grinding operation is for moves like this. Here is a starting point, and I move with the working speed. This is a working speed, and here you can define the way. I can move this way 10 millimeters, wait, and go back every time I make this operation, and I can start, or I can go return manual. So I go to this position with working speed, and then I can press the return button, and it goes back with rapid speed. So I make it something like this. It's like okay, and then I say go, and it moves 10 millimeters and returns faster. Okay, and I say automatic. Okay, and stop. This is a function for movements, and I have here it's a small LED, and I have to activate it. So this displays not change. You know, they have more or less the same function, but I can define easily the rapid moves and slow moves. So I can activate it and can have a look at here. I can change it, and Okay, I make this and say go 2 millimeters and this direction. Okay, and I can say 0 and again. Slow move. Or I can say rapid. Or rapid again. And I can say here, make it 10 millimeters and go. And go. Okay, I think that's all. Now here's a menu. I can define the delays here, or the default speeds, and the backlash from the ZX, and okay, that's all.